Write the equation for the graph given. So we need to start by looking at the shape of this graph to decide what the parent function should be. So because of the U shape, we'll go ahead and use y equals x squared as our starting point for our parent function. Now take a look at where the vertex is. Y equals x squared has a vertex at the origin at 0, 0, but this vertex is at -1, -2. So that means that we have had a shift to the left 1 and down 2. So we need to go ahead and take care of both of those shifts in our parent function. So a shift left 1 results in x plus 1, the quantity, being squared, and down 2 is a -2 on the outside of the parent function. Now, if I were to leave my equation like this, then the vertex would be at -1, -2, but then from the vertex I would be traveling over 1 and up 1 in both directions, and then from the vertex right 2 up 4, which would put me here, as well as left 2 and up 4. And so you kind of see what I have here in green. This would be the graph for the equation that I have created so far. And you'll notice that's not the equation that we've been given. So that means that we must have some sort of a leading coefficient here out in front that's impacting our graph. In this case, it looks like we actually have a vertical compression. From starting with the green graph and then changing to the black graph, that's a vertical compression. So we're expecting to have a fraction smaller than 1 as a leading coefficient. But we need to be able to find that leading coefficient. So for now, let's just call our leading coefficient A. So we have y equals A times x plus 1 squared minus 2. And we need to solve for A. So here's where you're going to go ahead and just pick a point. Pick a point that is on the graph that's given. Now we don't want to pick the vertex because we've already used the vertex in order to determine the shifting left 1 and down 2. So let's pick a different point. So let's say I'm going to choose the point 2, 1. And so I'm going to basically use this point to solve for A. So I'll be substituting 1 in for the y value, and I will substitute 2 in for the x value. And this gives us an equation that we can solve, and we can solve for the missing variable. We're solving for A. So it looks like we have 2 plus 1 is 3, and 3 squared is 9. Then adding 2 to both sides, looks like we have 3 is equal to 9 times A. And then division here, dividing by 9, leaves us with A is equal to 3/9, which simplifies to 1/3, which is what we expected. We did expect to have a fraction smaller than 1 because it looked like our graph was vertically compressed when compared with the parent function. So it looks like our equation now is y equals 1/3 times the quantity x plus 1 squared minus 2. Now, if you want to do some more checking, you could go ahead and go back up to your graph and pick a different checkpoint. For example, the only one we haven't chosen so far looks like this one over here, which appears to be -4, +1. So if you want to use that as a check, you certainly can. Just substitute 1 in for the y value, then substitute -4 in for the x value, and then question mark over the equal sign. Go ahead and simplify this and see if it gives you a true statement. So we know that -4 plus 1 is -3, -3 squared is +9, 1/3 times 9 is 3, and certainly 3 minus 2 does indeed equal 1. And it checks out.